Hi everyone, welcome back to Sciencelemst. I am Miss T, and today we are diving deep into waves. So grab your notebook and let's start learning. Don't forget to hit that subscribe button. Example 1, applications of definitions. So in this question, I gave you a diagram. In this example, I gave you a diagram and I asked you questions, meaning you need to use the diagram to answer the questions. So the first question asked, what type of wave is this? Can you remember? So this is a transverse wave. I can ask you further to motivate why you are saying it is a transverse wave. And there are two ways in which you can answer that question to motivate your answer. Can you think about it? Let me give you 5 seconds to think about it. Got it? Let's see. I know that these particles are vibrating. And how are they vibrating? They are vibrating at right angles. Where? To the direction of propagation of the wave. So that will be the first answer that I can motivate my answer with. Because the particles of the medium are vibrating perpendicular to the direction of propagation. The second way I can motivate, I can say because it has a crest and it has a trough. That makes it a transverse wave. Number 2, how many waves are there? Remember, one wave equals to one crest plus one trough. So let's find them. This is a crest, this is a trough, means one wave. This is a crest, this is a trough, meaning second wave. This is a crest, this is a trough, meaning third wave. This is a crest, this is a trough, meaning fourth wave. And then I end up with we end up with this portion. So this portion is only a crest, meaning it is just a pulse. So it means it gives me half of a wave. So the number of waves that I have here is 4,5. 4 complete waves and half of a wave. If they were asking you how many complete waves are there, then you will say 4 waves. But now the question was asking how many waves are there. Number 3, what is the amplitude of this wave? So if you look at the diagram, they gave you a height from the top to the bottom and they say it's 6 millimeter. Do you still remember what amplitude is? It is the maximum displacement of particles from where? From the rest position. So from this line going up there, I get amplitude. From this line going down there, I get amplitude. So now they gave me from the top to the bottom, they gave me 6 millimeters. And I just want half of that because that gives me amplitude. So it means to calculate my amplitude, I'm going to say A, it is equals to what? 6 divided by 2, which is equals to 3 millimeter. If I were to ask you to convert the 3 millimeters to a meter, do you know how to do it? Comment your answer in the comment section for me. Number 4, determine the wavelength of the wave. I'm given that the distance from this point to that point is 6 meters. And I just want to know the wavelength. Remember, the wavelength is the distance between two successive points that are in phase. So this gives me my wavelength, that gives me my wavelength, and that gives me my wavelength. So within the distance that is being given, I get 3 wavelengths. Okay? That's the first way I can look at it. The second way I can look at it is how many waves do I have covered within the distance. So from this point until this point, let's count how many waves we have. So here it's half of a crest. Do you see? And here it's half of a crest. If I combine this half of a crest and that half of a crest, I get one complete crest. And one complete crest and a half gives me one wave. Then I have a crest and a half gives me the second wave. And then I have a crest and a half that gives me 3 waves. So now for my wavelength, I can simply say wavelength is equals to the distance that is given divided by the number of waves that I have. And then my final answer will be 2 meters. If you want to be technical, you can say 3 times my wavelength is equals to 6 meters. Divide both sides by 3, divide both sides by 3. I end up with a wavelength is equals to 2 meters. Number 5, what is the period of the wave? So period, remember, it is what? It is the time taken for one complete wave to pass a fixed point. And remember, one wave is made up of a crest and a trough, succession of pulses, a crest and a trough. So if I look at this, that gives me one complete wave. How long did it take that one complete wave to pass this point? It took it 0.4 seconds. So from the graph, period, we use a symbol capital T. It's equals to 0.4 seconds. That is the period of the wave. Number 6, what is the frequency of the wave? Again, what is frequency by definition? Frequency is the number of waves to pass a fixed point in 1 second. So we're going to go to our graph and we're going to locate where 1 second is. There it is. So this is 1 second. So how many waves are there? Or how many waves are passing at that point in 1 second? Let's count. A crest and a trough, 1 wave. A crest and a trough, second wave. And then we have a crest. So how many waves is that? 2.5 waves. So the unit for frequency is given as Hertz. So our answer is going to be frequency, small f, is equals to 2.5 Hertz. So this is our first video, and we just used definitions to solve a question. So in our next video, we'll be focusing on calculations, formula for calculating period, formula for calculating frequency, and formula for calculating wave speed. Then we'll apply those in an example. So I hope you enjoyed this video. Don't let the technical stuff trip you. You're smarter than science. See you in the next video. Thank you for watching.